To look at some activities about the cloud chamber and indeed about radioactivity in general as well. So the first thing is review the cloud chamber video, same source if you've got it, or the link is there. And the first question is identify the diagrams of 3 possible tracks on that you'd see in a cloud chamber, and give a number by each of A, B and C. And then for activity 2, and keep pausing so that you complete each of the activities, you've just got to complete the details for alpha particles in the top row, and the last column is how does the decaying nucleus change with, in this case, alpha decay in terms of its position in the periodic table, in terms of group changes, etc. And then activity number 3, complete the following nuclear decay equations. And where there's a question mark, which particle is going to be emitted, and give its symbol, the mass of the particle and the atomic number of the particle. I won't say if it has one. And at the bottom it shows that actually gamma rays are often emitted as well, but we're not writing them in the same way because the gamma rays have zero mass and no position in the periodic table. It's a high energy output. They're not always written in the balanced nuclear equation. And it asks you to list 2 main rules you need to know to be able to write nuclear equations. So pause so you finish those activities. And then we've got a picture from outside the Earth's atmosphere and cosmic rays, with several questions that are related to use of a cloud chamber as well, particularly if you remember having seen the video. And so pause to answer that question. The next one is looking at a track, and you've got an arrow at the start of an alpha particle track, and what you're asked to do is to follow the track into the white circle, describe what is happening. Can you explain what is happening? The black line and the theta is only put there to show the angle of moving. And answer it in terms of what other materials are present that might affect the motion of the alpha particles. So pause that one to go on as well. And we're talking about the name Rutherford scattering. So we're looking at the deflection that's occurring, and does the reference to a gold foil experiment support your explanation for what was happening because of the deflection in the track of the alpha particle? And again, pause to answer that question. Then you're going to look at the diagram, and it says carefully, because I want you to know and to be able to recall the features of a cloud chamber, which actually helps describe how it works as well. So pause this to absorb each of the labels and indeed the design diagram. And when you move on, label the diagram. So what are the features that we can see? This is a bird's eye view above the cloud chamber, and if there's anything you can't see, just list those components separately. And again, pause. Activity number 9, why are the tracks seen here close to the alpha particle source? And you can pause while you answer that. Why are the tracks at an angle from the source? rather than in the direction of the source. Identify what that is as well, which may help with your answer. And pause while you do it. And here you're being asked to look at the tracks more carefully. Can you identify a longer, slightly curved track coming from the radioactive source, which is the white blob from the gas mantle on the left? And what particle will have formed this track? And then the next two slides are to estimate your exposure to radioactivity over a year. And there's an average dose in millirems per year, and it's, if you like, well within the exposure possibility of the humans. The limits for people working in nuclear facilities of 5,000 millirems. And so go through each of those. Radon is given from rocks. It depends on which region of the US that you are, so you'll just take one of those across to the line. Experiencing carbon-14, potassium-40 isotopes, again you're given that amount. Living in a house, brick, stone, concrete, you're adding some millirems. And then cosmic radiation is greater the higher elevation that you live. So pick your elevation of where you live and spend most of your time. And then add that as a subtotal, because you're going on to the next session. Those were natural sources. Artificial from X-rays, maybe dental X-rays, other parts of the body. Upper digestive tract is a larger number. Nuclear medicine with imaging and CAT scans. And then watching TV, working with a computer. Air travel, 1 millirem per 2-hour flight. So do the calc if you have flown how many hours to do that. And then add the subtotal as well as the artificial radiation. And then you might have to come back, scroll backwards, because asking you to fill in the sort of percentage areas on a pie chart, how they vary for each of those regions A through G, and what elevation does the pie chart show? So you really do have to go back, and which part of the US is it living in? Here it's assuming 1 CAT scan and 8 hours of flying plus a head X-ray. You can, as an extra one, do a pie chart for your own specific personal exposure. And then activity number 14, a tray at the bottom, experiment done in a fume hood, got some liquid nitrogen there. What would the difference be to your cloud chamber experience if you had liquid nitrogen, which is at a temperature of minus 196 degrees Celsius, rather than the solid CO2 dry ice at negative 78 degrees Celsius around the base of the cloud chamber? And that's the last of the questions. And we're thanking Washington International School and their team science. And now we're going on to some answers. And I'm just going to let you read those rather than give a dialogue with it, and give you 3 or 4 seconds on the video, but indeed pause them to read for longer and to absorb the information and compare them to yours.